Hi, welcome to LearnAid. In today's question analysis, we'll be looking at arc length, and we'll use question 7 from the 2016 VCAA exam 1 as an example. So the question asks us to find the arc length of this curve from x equals 0 and x equals 2. I've also added the arc length formula and a chain rule formula for our convenience we'll be using later on. Notice that the arc length formula has two forms, one that uses x as its terminals or t as its terminals. Since we're only given x equals 0 and x equals 2, we must use this as our terminals, and therefore we'll use this form. Also, notice that the function here is f dash x, meaning that we must differentiate this function. Let's let y equals to fx, and therefore f dash x will be 1/3 dy dx x squared plus 2, 3 on 2. Notice that this is actually a chain rule. So what we can say is, let's say y is x squared plus 2, 3 on 2, and we'll let u equals to x squared plus 2. And therefore y is u to the power of 3 over 2. Now, in the chain rule formula, we need dy du and du dx. So let's get dy du first. Dy du is simply just the differentiation of this. So we'll get dy du as 3 on 2 u to the power of 3 on 2 minus 1, which we'll get to be 3 on 2 u to the power of 1 on 2. Now let's get du dx. All we have to do is differentiate this. So du dx is 2x. Now let's fit everything back together. Dy dx is dy du multiplied by du dx. And dy du is 3 on 2 u to the power of 1/2 multiplied by du dx, which is 2x. We can sub back in u, and since u we said is x squared plus 2, we can simply write this as this. Let's fit everything back together, and therefore f dash x will be 1/3 multiplied by 3 on 2 x squared plus 2 to the power of 1/2 multiplied by 2x. And here, what we can notice is that the x's, the 3's cancel out, and the 2's also cancel out. So what you'll get, the most simplified form would be x squared plus 2 to the power of 1/2. Let's now work out what the arc length is. We can now sub in x2 as 2 and x1 as 0, as given by the question. And we can write this as L, which is the arc length, is 2 to 0 to this, and then square root of 1 plus f dash x, which is x squared plus 2 to the power of 1/2 all squared dx. Now let's simplify this. We can write this as same thing, 1 plus, but now let's multiply the square into the brackets, and we'll get x squared plus 2, 1/2 multiplied by 2, which just gives us 1 dx. And so we can write this as 1 plus x squared multiplied by x squared plus 2 dx. And this will give us 1 plus x cubed plus 2x squared dx. Now, let's further simplify this. Let a equals to x squared. So length would be 1 plus a squared plus 2a dx. And let's factorize this. A squared plus 2a plus 1 would be a plus 1, which is a plus 1 squared. Now, this is perfect, since we can cancel out the square root. A plus 1 squared dx. And this square will cancel out with the square root, giving us a plus 1 dx, where a is x squared. So x squared plus 1 dx. Now we can integrate this normally. X cubed on 3 plus x, and brackets 2, 0. And so we'll get 2 to the power of 3 over 3 plus 2 minus 0 on 3 plus 0. This gives us 8 on 3 plus 2 minus 0. And 8 on 3 plus 2 will be 8 on 3 plus 6 on 3, which will give us 14 on 3. So I hope you find this helpful. Thank you very much.